Conics and Calculus. In your earlier pilgrimage in mathematics, you have dealt with conics before, how to identify a parabola, its vertex, directrix, and those kinds of things, how to identify an ellipse, um, hyperbola, circles, how to graph. I will not bore you with the details of such, but I will just in a general sense consider a general equation and how to simplify the general equation so that it looks like a circle equation, a parabola equation, ellipse equation, or a hyperbola equation. And then from there, just give a general sketch of the graph without the details by which typically you would see in the conic section. 4 basic graphs for the conics: the circle, the parabola, the ellipse, and hyperbolas. I think the standard equation for the circle, I think you're most familiar with that, where h and k is said to be the center, r is the radius. Let's change it up. See if you have a center. Well, let's talk about a parabola. The parabola has the definition that it's a set of all points x, y that are equal distant from a fixed line that we call the directrix, and from a fixed point that's called the focus, where the focus is not on the line of the directrix. So here we say that equal distance, that is, if I take any point on the so-called parabola, that the distance from the focus to the directrix will be the same. Whatever point you take on the parabola, its distance from the focus to the directrix would also still be fixed or constant. I will not bore you with the details of the parabola equation. I think it's very straightforward, and I will show you in just a moment. Next, if it's an ellipse, the definition of ellipse is that set of all points x, y where the sum of whose distances from 2 fixed points called the foci is said to be constant. So if I take any point on the so-called ellipse, it's said here that the sum, that is the distance from this focus to the point, and then from the point to this focus, here those distances will be constant. In other words, if you take from this point and you measure that, here, those distances will also set to be constant. You'll get the same sum as you did for D1 plus D2. And it doesn't matter wherever you go. Oops. If you're here, you take this distance, that distance there, at this point, and those distances, the distance from here to there added up will be the same as this distance from here to there added up, and the same thing as D1 plus D2. Hence, we call that an ellipse. I will give you just very straightforward methods in terms of how to solve. We have the equation for the ellipse. The ellipse and the hyperbola equations will be similar. The only difference is that for the so-called hyperbola, there'll be a negative sign. But for the ellipse, both terms, the coefficient is said to be positive. For the hyperbola is the set of all points. Instead of adding the distances, here we subtract and take the absolute value. And so the absolute value of the differences between the two fixed points, between a point being measured from the two fixed foci, is set to be constant. So they take this point here, D1, and so the distance from the focus to this point, XY, excuse me, to this distance to this focus, D1, D1 and D2, we take the difference of that, and not just the difference, but the absolute value of the difference to make sure it's positive, a positive length, will be constant. If you take from up here, you get the same constant distance of the differences by all means. What about some problems? Write the conic equation in standard form, which will either be a circle, parabola, ellipse, or hyperbola, and then from there graph the results. So need to note that, let me put this in here. Complete the square to simplify the general equation. Complete the square to simplify the general equation. Okay, I think that's good. I want to type that just to make it more significant. Now, let's work this problem. So we're going to get the like terms together. Well, they are together here in that sense. So this is y squared minus 4y. I'm going to complete the square on y because y is squared. Take half of negative 4. We get negative 2. We square it. We get 4. So we're going to add a 4 here, basically to both sides of the equation. Let's go ahead and add the 4x on both sides. So this is 4x plus 4. And so this is y minus 2 to be squared is equal to this 4 times x plus 1. Now, according to the to the definition, the vertex for this problem is the point -1, 2. And so we seek to graph this. This is y squared, so the parabola will curve either to the left or to the right, and it will curve to the right if the sign over here for 4, if this number is positive, it curves to the right. This number is negative, it curves to the left. If it's x squared, then the parabola goes up or down based on the power or the sign. If it's positive, it curves up. That is for x squared. If it's negative, it curves down. So we find the point. This is x-axis, y-axis. X is -1. Y is 2. And so the sign is positive, so it's going to curve to the right. And again, we're just sketching. Okay, get the idea. There was another problem. I guess that's it. There was another problem that was similar to that one that I thought I wanted to work. That problem there was very lame. Anyway, let's look at this one. So I'm going to get the like terms together to set up the completion of the square method. So I'm going to factor out a 9 from the x terms. Factor out a 4 from the y terms. Complete the square on the x terms. Take half of 4, we get 2. We square it. We get 4, so we add 4 and subtract 4 within the parentheses. Plus 4 times y squared minus 6y. Take half of the -6, we get -3. We square it, we get 9, and we subtract 9. Plus 36 equal to 0. So this is 9 times x squared plus 4x plus 4. Take the negative part out, so 9 times -4 is -36 plus 4 times y squared minus 6y plus 9. Take the negative part out, gives us -36 plus 36 equal to 0. Those two guys go out. We're going to add 36 to both sides. We get here 9 times x plus 2 to be squared plus 4 times 9 minus 3 to be squared. That's equal to 36. Divide both sides by the 36, and so that gives us x plus 2 to be squared all over. 9 divided by 36 is 4. I'm going to write this as 2 squared plus y minus 3 and this is 4 divided by 36 gives us with the 9. So I'm going to write that as 3 squared is equal to 1. So here, since both of the coefficients are positive, it's an ellipse. And with vertex, or let me say here, center, at -2, 3. So what we do here is we find the center. Oh, by the way, A is ±2, and the B is ±3. So we find the center. X is -2, Y is 3. And so from the center, we're going to go up. Y is ±3. We're going to go up 3 and down 3. So it brings us here. Then we're going to go up 3. 1, 2, 3. Puts us about there. And then for X, we're going to go to the left and to the right 2 units. So coming over 2 units puts us here, and going over 2 units puts us about there. And then we're going to draw an ellipse based on that shape there. Do the best you can without drawing Wendy. You know, Wendy's restaurant. But anyway, kind of looks like Wendy with the red. So now here we collect the like terms. So 9x squared plus 54x minus 4y squared plus 8y plus 78 equal to 0. Factor out a 9. Factor out a 4. Complete the square on this x. So we take half of 6, we get 3. We square it, we get 9. So we're going to add 9 and subtract 9 within the parentheses. Minus 4 times parentheses y squared minus 2y. Take half of -2, we get -1. We square that, we get 1. So we add 1 and subtract 1 within the parentheses. So now we're going to take the negative part out and then complete the square. That is, just get the perfect square trinomial. This is x plus 3 to be squared, then minus 81. 9 times -9 is 81 on the outside. Minus 4 times, look at these 3 terms here. It gives us y minus 1 to be squared. -4 times the -1 is plus 4 on the outside. Plus 78 equal to 0. So we get 9 times x plus 3 to be squared minus 4 times y minus 1 to be squared. We get 82 minus 81 is plus 1. So on the opposite side, it becomes -1. So now what I would do to get this into the standard form is to divide through by this 9, and that will leave me with a 4 times y minus 1 to be squared minus 9 times x plus 3 to be squared is equal to 1. I'm going to write this in the form that we like because we talk about these hyperbolas or ellipses with this type of form, y minus k to be squared over b squared. Here this is a minus x minus h to be squared over a squared is equal to 1. So writing this equation in that form, that gives us y minus 1 to be squared all over 1/2 squared minus x plus 3 to be squared all over 1/3 be squared is equal to 1. Now the ellipse, not the ellipse, excuse me, this is the hyperbola. The hyperbola will shift with respect to the variable axis that has positive coefficient. So here the y has a positive coefficient. So the hyperbola will tend up and down with respect to the y-axis. If this was positive in front of x and negative over here for y, then the hyperbola would run to the left and to the right with respect to the x-axis. So we find, it's supposed to be a y. So here we find the so-called center. It's -3, 1. So we find that. So we're there. Now what we're going to do is notice that B is plus or minus 1/2. And the C is plus or minus 1/3. This is the A, excuse me. And it'll be somewhat hard to try to get the shifts in terms of moving a half, which is kind of straightforward. We can do that, but the third, we have to do some estimation. So what we do from the center for x plus or minus, we go to the left and to the right, a 1/3. So we're going to shift over 1/3. So it's not as much as a half. So I'm going to go here, let's say there. And then from the center, we're going to go up and down a half. Now from there, you want to be able to draw the rectangle. Exemplify it. And then draw the so-called isotopes that will go through the diagonals. Okay. Now, since the coefficient for y is positive, then the hyperbola will shift with respect to the y-axis. Okay, I'll just leave it as that. Now, all of the dotted lines do not, you can't even see those. Those are said to be isotopes, so they're not visible by us, but the graph knows how far to go. An invisible electric wire for the cows. Yep. Alrighty. Well, I think that'll do it for now. Thank you.